Hey friends, in this video we're going to talk about how we can insert n number of elements between two numbers, let's say a and b, such that the whole resulting sequence will be in AP. So let's say the first is A and the last is B, and within this A and B we want to insert n number of elements, let's say A1, A2, A3 up till AN, and the last one is B. So that's the solution. Now one very important point here is to be noted over there is that here small a is the first element and B is the last element. So in here, in this sequence, we have n plus 2 elements in total, because A1 to n is in which we have n number of elements, and A and as well as B. So in total we have n plus 2 elements. So as we know a formula, that is An is equals to A plus n minus 1 into D. This one is the nth term, A is the first term, and D is the common difference. So if we put on this formula for this sequence, what we'll get is An, it will be B, because this is the last term or the nth term in the sequence, not particularly the nth term. This is the n plus 2th term, to be more precise. Okay, now B is the n plus 2th term. Now over here we have A is the first term, so A. Now n is n plus 2. Here n will be n plus 2. This one will be A plus 2 and this one will be n plus 2. I think you know why. Because in this sequence, in this particular sequence, we have in total n plus 2 elements, right? So n plus 2 minus 1 into D. That from here we will get B is equals to A plus n plus 1 into D. Right. Now in here we have to find the value of D. So D will be, if we can see, B minus A, will take A to the left side by n plus 1. So that will be D from this particular equation. D will be B minus A by n plus 1. Now we have to find this A1, A2, A3 and up till AN, so that we can insert these particular values between the two values A and B. So to find A1, what will we write? We will write something like this: A1 is equals to A plus, because as we know A is the first term. Now A1 is, as we know, the second term of our sequence. Now if we can see A1, it is the second term of our sequence. So we'll write A plus 2 minus 1 into D, and as we know that A plus 2 minus 1 will be 1, and further we can write as A plus, we got D as B minus A by n plus 1. B minus A by n plus 1. So we can easily find this A1 from here, because we know the value of A, we know the value of B, we know the value of n. So we can easily find A1. And similarly, if we go to the next A2, we have to A2 is the third term. As you can see, it is the third term of our sequence. So A plus 3 minus 1 into D. Over there A plus 2D, and further we can write it as A plus 2 into B minus A by n plus 1. We can find A2, and similarly so on, and we can also find AN. That will be A plus. One thing is to be noted over here is AN is the n plus 1th we can say element, because this is the first element, this is the first element, this is the second, third, fourth. So as we can see that A1 is the second element, A2 is the third element, A3 is the fourth element. So we can say that An is the n plus 1th element of the sequence. An is the n plus 1th element of the sequence. So in here we can write it as n plus 1 minus 1 into D, and further we can write it as A plus nd, where D can be written as B minus A by n plus 1, right? So we have seen how we can find all the n elements between two particular elements, and this particular series, or not series exactly, it is sequence. This particular sequence will be in AP. So let's head on with an example to make the things more clear. So let's say we have to insert 6 numbers between 3 and 24 such that the whole series or the whole sequence will be in AP. So as we know, 3 will be in the first one and 24 will be the last one, and we have to insert 6 numbers: A1, A2, A3, A4, A5, and let's say A6. So these are the 6 elements that we have to insert such that this whole sequence is in AP. So we'll just follow the same path. As we know, 24, as the number of terms in the sequence is 6. A1 to A6 is 6 terms, this one 7th, let's say this one 8. So we have n equals to 8, that is total number of terms is 8. So we can write this formula An equals to A plus n minus 1 into D, and we can use the formula, and 24 is equals to An is the last term is 24, first term is 3, n minus 1, as we have counted the total number of term is 8, so 8 minus 1 into D, and we don't know D. So let's write D. So that will be 3 plus 7D equals to 24. To be more precise, 7D is equals to 24 minus 3, that will be 21. D will be 21 by 7, that will be 3. So we got D as 3. Now we can easily find all the numbers that we want to insert, that is A1. Let's find A1. So A1, as we know, is the second element of our sequence, so that will be A plus 2 minus 1 into D, as we know, and A is, as we know, A is 3, and D is, as we know, A is 3 and D is 3. So what we can write, A is 3, 2 minus 1 1, and D is 3. So the A1, that is the second element, will be 6. Now A2, let's change the color. Yeah, A2 will be A plus, it is the third element of our sequence, so 3 minus 1 to D, A plus 2D, A is 3, and 2 into D, that is 3 into 2 6, and plus 3 9. So now we can easily find our whole sequence, because we know A, we know D, so we need not always write this A3, A4, and by using this formula we can easily write the whole sequence. So what will be the sequence? As we know, A is 3 and D is also 3, so obviously our AP sequence will be 3, then 3 plus 3 will be 6, 6 plus 3 will be 9, 9 plus 3 12, 12 plus 3 15, 15 plus 3 18, 18 plus 3 21, and then plus 3 24. Our last term is 24, our first term is 3, and within this we have to insert 6 terms, and we have done it. So I hope you got how we can insert any number of terms within two different numbers and keep the whole sequence in AP. If you have any doubt, you can comment down below, and thanks for watching.